Okay, welcome to the video version of the material from Chapter 3 of Basic Sentential Logic and Informal Fallacies. This will be covering the material in Section 3.3. What we have done so far in 3.1 and 3.2 is introduce a proof method and the first two inference rules, modus ponens and modus tollens, and we ran through some examples. What we're going to do now is introduce three more inference rules and then see some more examples. So the next one is disjunctive syllogism. We'll abbreviate that as DS. And what this rule says is that if you have a disjunction on one line and you have the negation of one of the disjuncts, then you can infer the other disjunct. So in this written version of the rule, there's a disjunction, there's a negation of the first disjunct. Okay, the first disjunct is phi, and on another line you have not phi. So on a new line you can write psi, which is the other disjunct. This basically encapsulates the pizza argument that we saw in Chapter 1. Next up is hypothetical syllogism. This rule says that if you have two conditionals, okay, which we have here, if phi then psi, and if psi then chi. And those two conditionals are such that the consequent of this one is the same as the antecedent of that one. Okay, so we have a match. Then you can infer a new conditional that has the antecedent of the first, phi, and the consequent of the last, chi. Another way to think about this is you can think of this as a chain. If phi then psi, if psi then chi, almost like you're going from here to here and then that leads to that. So you're sort of cutting out the middleman. You're saying, okay, well this will lead to that then. There's an intermediate step, but you're cutting that out in the representation here. So this would be something like, if I buy a cat, then there will be fur on my furniture. If there's fur on my furniture, then I will have to vacuum. Okay, so if you know those two conditionals are true, then you know that if I buy a cat, then I will have to vacuum. Okay, so it's pretty intuitive. The last of the three we're going to introduce now is simplification. And this is actually simple, as the rule indicates. If you have a conjunction, then you can write either conjunct by itself on a new line. Okay, in this case I wrote the second conjunct, but you could also simplify the first conjunct. All right, let's see some examples. So one good thing you can always do, one approach to proofs, is to just start applying rules. Right now we have 5 rules. Let's look and see if any of those rules can be applied. Now, 3 of our rules require conditionals. Okay, modus ponens, modus tollens, on hypothetical syllogism all work on conditionals. Okay, and we have 2 that don't require conditionals. There's disjunctive syllogism and simplification. Now, if you look at our the lines we have so far, 1 and 2, you can see neither of them as a conditional. Okay, now this is an important point, and I'll come back to it later. You might think, well, hey, Rick, actually we do have a conditional. Look right here. If E, then not G. True, there's a conditional here, but it's not the entire line. Premise 1 is a disjunction. Okay, yeah, its second disjunct is a conditional, but the rules have to apply to entire lines, and I'll talk more about that later. So the whole line would have to be a conditional. And here the whole line is a disjunction. So the only 2 options for us would be disjunctive syllogism. And we do have a disjunction, but we don't have the negation of either disjunct. Now you might say again, oh wait, Rick, we do have the negation of one of the disjuncts right here. Well, again, this has to be on a line by itself. Okay, line 2 is not the negation of that. Okay, line 2 is a conjunction. The first conjunct is the negation of that. Well, that's good news because one of our rules is simplification. So we can actually get this first conjunct out by itself. In fact, we can get both of those conjuncts out, which I'm going to do. So I'm going to do the rule of simplification twice to simplify both of these conjuncts off on lines by themselves. So now I've got more pieces to work with. In particular, one of these pieces, not D, is what I need to do disjunctive syllogism up here. Okay, so before I do that, let me just remind you of something. In the rule of simplification, the way it's written, like I said, it's the second conjunct that got simplified, but you can do the first one as well. And in fact, this is an example. On line 3, I simplified the first conjunct off. In line 4, I simplified the second. And in line 4, I simplified the first one off. No problem. Okay, let's go back to the proof. So now I can do disjunctive syllogism. I've got a disjunction on line 1. Line 4 is the negation of the first disjunct. Okay, it's a negation of one of the disjuncts, so I can infer the other disjunct, in that case the second one, if E then not G, which I'll put here on line 5. And that's from disjunctive syllogism on lines 4 and 1. Now what can I do? Well, remember what we said earlier. We said, we can't work with this conditional because it's not on a line by itself. Well, now it is. We managed to break it off with disjunctive syllogism. So now it is a line on itself. So now we can do something with that. We could do a modus ponens or a modus tollens, or use it with a hypothetical syllogism if we could. There's only one we can do, though. We can't do modus ponens because for modus ponens we would need E, and we don't have E up here. And we can't do hypothetical syllogism because that requires two conditionals, and this is the only one we have. But we can do a a modus tollens, because we do have the negation of the consequent right here on line 3. So by modus tollens, we can get the negation of the antecedent, which is cool because that's the conclusion. And so this proof is done. So this was, we got this by using the rule of modus tollens on 3 and 5. Okay. 5 is a conditional, 3 is the negation of the consequent, so by modus tollens we get the negation of the antecedent. So E becomes not E. Okay, let's do another example. We have 4 premises. We're trying to get if B, then D. Again, why don't we just start off by just doing whatever we can and see if something interesting pops up. So if you look at this, you can see there's only three things we can do right now in terms of what we can do with our rules. We can do simplification, so we could simplify off this conjunct or this conjunct. So that's 2 things we could do. There's a third thing we can do. We could do disjunctive syllogism with 2 and 3. That's a disjunction. We have the negation of that disjunct. We could derive the second disjunct. We don't have anything we would need to work with this conditional yet. We don't have the negation of K for modus tollens. We don't have negation of this conditional for modus ponens. So far we're limited to those 3 options. I'm going to go ahead and do the disjunctive syllogism first. Okay, on lines 2 and 3 to get not K. Now you can see now I do have the negation of that consequent, so I could do modus tollens to get if A then D. Okay, conditional, negation of consequent. I'm going to infer the negation of the antecedent. Well, this is the negation of the antecedent, and I can negate that. This is the antecedent. I can negate that by removing a tilde, in which case I'll just get if A then D. Okay, next up, what I'm going to do is simplify the first conjunct of line 1. If B then A. And now you can see that, well, maybe you can see, we are exactly 1 step away from finishing the proof, because we can do a hypothetical syllogism on 6 and 7. Notice here on 6 and 7 we have 2 conditionals, and we have a match between a consequent and an antecedent right there. Okay, so these 2 match. So this is the one that we're going to eliminate. This is the middleman here, the A, and instead we're going to go if B then D. We're going to go from the beginning straight to the end. Okay, If B, then D, hypothetical syllogism on 6 and 7, and that's the conclusion. So we are done with that proof. Okay, now that we've got a few examples under our belts, I want to talk a little bit about some specifics, things you can't do, and then some things you can do that hopefully will eliminate some errors on exams. So one thing, and I've mentioned this before, but I want to make it explicit now, whole lines in the rule, and by that I mean the sort of written schematic version of the rule, must correspond to whole lines in the proof. So what does that mean? Well, here's modus tollens, okay? And this is legit because in the schematic version of the rule, we need a conditional, and that corresponds to the whole line. This whole line is a conditional. We need the negation of the consequent. That's legit because on line 2, we have the negation of the consequent. We infer the negation of the antecedent, A. What you couldn't do is this. Suppose line 2 was this, not Q or K, right? What you couldn't do is say, oh, hey, look, I've got a conditional, and here's the negation of the consequent. I've got not Q here, which is the negation of that, so I'm going to get not A by modus tollens. No, you can't do that. Why? Because the negation of the consequent would have to be the entire line. Line 2 would have to be, the whole line would just have to be the negation of the consequent, and it's not. It's a disjunction, and part of the disjunction is the negation of the consequent, but there's more stuff here. Okay, so you couldn't do that. What else can't you do? Well, the operators specified in the rule have to be the same ones that you have in the lines of the proof that you're applying the rule to. So for example, here's modus tollens again. This is the same thing. You have a conditional, negation of the consequent, negation of the antecedent. What you couldn't do, though, is say, oh, look, maybe I can use the rule of modus tollens on a disjunction, right? So I've got a disjunction. I've got the negation of the component on the right, so I'm going to infer the negation of the component on the left by modus tollens. No, because modus tollens requires a conditional. Okay, and if this isn't a conditional, then you can't use the rule on that. Okay, so it has to be the same operator. So I'm going to put a red X there to indicate do not do that. What else can't you do? Well, this isn't so much what you can't do, but it's something that you should be careful that you do correctly. When you're negating something, which you have to do a lot, right? You can infer the negation of the antecedent. So you have to take the antecedent and negate it on your new derived line. Make sure you're negating the correct statement. So what you might do, someone might do something like this. They might say, okay, modus tollens, I'm overusing modus tollens here, but that's okay. I've got a conditional, I've got the negation of the consequent, so I'm going to infer the negation of the antecedent. Well, what's the antecedent, A or B? I need the negation of that, so I'm going to put A or B here and then slap a tilde on the left. Well, that's not right. Why isn't it right? Okay, well, it's not right because what I need to do is to negate the antecedent, and the antecedent is this disjunction. So I would need to negate the disjunction. All this is doing is it's leaving the disjunction as it is and only negating the first disjunct. Okay, so you shouldn't do that. What it should look like is this. Okay, so this is the negated disjunction. Okay, I have the tilde out here. Okay, so make sure when you're negating things, you're negating the correct statement. This is kind of related to the next thing that you shouldn't do, which is to distribute negation operators. So let's go back to this, which is the same one I just had up. And the derived line in the end is not A or B, the negation of A or B. Some people sometimes ask, well, instead of that, could I write not A or B as not A or not B? Which would be distributing the negation operator. And the answer is no. Not A or B is not equal to the negation of A or B. Okay, so if you have this, just keep it this way. Don't rewrite it as that. And vice versa. If you have something like this, don't just rewrite it as that and assume it's the same, because it's not the same. In fact, if you do a truth table for these two statements, you'll see that they're not equivalent. And this also applies to conjunctions, right? So this example is a disjunction, but you also, so you can't do that. Also applies to conjunctions, right? Not A and B. Don't rewrite that as not A and not B, because it's not the same. Okay, what can you do when applying inference rules? Well, you do have some latitude and things that can be done. So I want to talk about that. So one is that the order of the lines in the rule need not be the same as the order of lines in the proof. Okay. Now, of course, the derived line has to come after the lines that it's derived from, obviously, so that your newly derived line comes at the end. But the lines you're applying the rule to don't have to be in the same order as they show up in the schematic version of the rule. What does that mean? Well, here's an example of modus tollens again. And as you can see in the schematic version of the rule, the conditional here shows up above the negated consequent, which is in fact right here, right? We have the conditional and the negated consequent below it. But they could come in a different order, right? You could have the conditional below the negated consequent. In fact, they don't even have to be next to each other. And this came up in some proofs we did a little bit earlier in this video. Okay? So here I'm just indicating that these are in different order. Now, what can you do? Or another thing you can do, which is you can cite the lines in any order you want. So what do I mean? And by that I mean in the justifications. So here's an example where we've cited modus tollens to get A. Okay, conditional, negation of consequent. Here I've negated the antecedent. I've justified that as 1-2 modus tollens, but I could equally well have said 2-1 modus tollens. So the order that you put the numbers doesn't matter. The number should come before the rule, so it shouldn't be modus tollens 1-2. It's not the end of the world if you do that. When the exam's graded, they might take off a point. So I would just put the line numbers first and then the rule after that. Some more stuff you can do. For simplification, you can simplify either conjunct. So I already kind of talked about that. In fact, we saw an example where we simplified both conjuncts off, the first and the second. For disjunctive syllogism, you can have the negation of either disjunct. So for example, in this case, disjunction, negation of the first disjunct. So we're deriving the second. But you could also have, as in this case, the negation of the second disjunct, and you derive the first. Either of those is fine. Okay, let's do another example. This one's going to be kind of fun. We've got 5 premises, and the conclusion is not J. What can we do? Well, we can do a simplification here. On line 2, we've got on 1 and 5, we have what we would need for disjunctive syllogism. We have a disjunction and we have the negation of the first disjunct here. What I'm going to do is I'm going to go ahead first and I'm going to simplify from line 2 the second conjunct. So I'm going to get if H then not J here. Now I'm going to go ahead and do that disjunctive syllogism on 1 and 5. Okay, so this is the negation of the first disjunct, so I'm going to derive the second disjunct, H or H. Now you might think, H or H, that doesn't make any sense, right? If you translate that back into English, that would be something like either Bigfoot is hairy or Bigfoot is hairy, right? No one would actually say that in English. Don't worry about that. We've got the symbols, we've got rules to apply the symbols, we can work with them. Right now we don't have to worry about whether anything makes sense, which is good because if we waste a lot of time trying to translate these things into English and worry if they make sense. So we're just going to go with it. Okay, now if you notice line 6 is the antecedent of 4. So I can do modus ponens to get if H then R. Okay. And now I'm going to go ahead and, well, let's see. Yes, I'm going to go ahead and do a modus or simplify off not R. As I see, I have this conditional. If I had the negation of that, I could infer the negation of this. And I got the negation of that. I have to simplify it off from line 2. So now I have not R from line 2 simplification. Now, what I'm going to do is pause for a minute and see if I can figure out where I'm going with this. So what I've done so far is I've just been kind of applying rules as they've sort of occurred to me that I can do it. And I could keep doing that, which would be fine. But now I'm going to try and make a plan. So what I'm going to do is, this is another way you can approach proofs. You can sort of try and work backwards. What does that mean? Well, I'm going to look at where am I trying to get? Where's my goal, my end point? Well, my end point is right here. It's not J. How could I get not J? Well, not J shows up here. If I could get H, I could get not J by modus ponens. Also shows up here. If I could get R and D, then I could get not J by modus ponens. Well, I've got D. Do I have R anywhere? Now I've got not R. I've got R here, but I would need H to get that. How can I get H? Well, I have H or H. Okay, I'm befuddled. Not sure how to do it. Well, there is a way. I can get H. Now, of course, well, I'll show you how that works. You're gonna like this. First thing I'm gonna do is get not H. So I have the negation of R. I'm gonna get not H by modus tollens on 9 and 8. Well, you might think that's counterproductive. I wanted H, and I just derived not H. Maybe that means I can't get H, right? Because that's the negation of the thing I'm trying to get. How could I get the opposite of it? Well, if you look at lines 7 and 10. 7 is a disjunction. 10 is the negation of the first disjunct. So by disjunctive syllogism, I can derive the second disjunct on a line by itself. Okay. Notice that in the verbal description of the rule, okay, which I'll repeat again, it says if you have a disjunction and you have the negation of one of the disjuncts, you can infer the other disjunct. Nowhere in the rule did it say that in the disjunction, the disjuncts had to be different. Okay, it leaves it open that they might be the same, and in this case, they are the same. All right, so I have the negation of one, I'm deriving the other. So I've got H. So now I can get not J, right? Because I have H. On line 6, I have that conditional, so by modus ponens, I can get not J. Now, some of you watching this might be having the following thought. Look, 10 and 11 are just negations of each other, okay? How could you derive both of those? It's a contradiction, okay? Or you might put it more pointedly. You might say, look, Rick, you told me in section 3.1, chapter 3, that the rules are truth-preserving, which means that if you apply the rules to true lines, lines that are only true, you will only be able to derive true things. But look, we know that we had to have derived something false because we don't know which one of these is false, but one of them has to be false. If H is true, not H is false, and vice versa. So we know one of these is false, so we know we derived something false. How could we do that with truth-preserving rules? Does that mean we screwed up somewhere? No, it does not mean we screwed up. What does it mean? Well, it means that the things we were applying the rules to can't all have been true. Okay. If they were true, we could never derive something false. We would never be able to derive this, which means that these things can't all be true. In particular, what that means is that they're inconsistent. If you do a truth table for these premises, you'll find that there's no row on which these are all true. It's not possible for these to all be true at the same time. Okay, and that's why we managed to derive this contradiction here, derive something false. At least one of those is false. Okay, well now you might say, well gosh, Rick, now I'm even more confused because I thought that the whole point of the proof method was to determine argument validity, and we're assuming the premises are true and then seeing if we can derive the conclusion from those premises. And if we can, we've shown that if the premises are true, the conclusion has to be true. But now you're saying it's possible that we have premises that aren't all true, that are inconsistent. Okay, A, good point. B, here's why that isn't a problem. There's two possibilities. Either the premises are consistent, in which case it's possible for them to all be true at the same time, and then no problem. We can just do the proof method to determine argument validity. Or the premises are inconsistent, in which case the argument is going to be valid. Okay, any argument with inconsistent premises will be valid. And if there's inconsistent premises, soon you will definitely be able to derive the conclusion, okay, as we did here. In fact, and there will be examples of this, I think, before too long, anytime you derive something like this, a statement and its negation, you'll be able to derive anything in 2 or 3 lines. So if the premises are inconsistent, yes, you'll be able to derive the conclusion, but that's okay because if the premises are inconsistent, the argument's definitely valid. Why is that? Actually, you should be able to answer that when we finish chapter 2, actually. If the premises of an argument are inconsistent, will it be valid? Yes. Why? Because you'll never find a counterexample row. Right? If you did a truth table for this argument, right, you just had these 5 premises and this conclusion, and then you looked for a counterexample row, right? You want to know, do these premises jointly imply the conclusion? You'd be looking for a row where all of these are true, but that's false. Well, if these are inconsistent, you won't find a row where all of these are true. That's what inconsistent means. They can't all be true at the same time. So because of that, you'll never find a counterexample row. You'll never find a row where these are all true, and that's false. So no counterexample row means the implication holds, which means the argument's valid. So that's why it's not a problem. If the premises are inconsistent, yes, you'll be able to derive the conclusion, and the argument's valid, so the proof method works. If the premises are consistent, that means they can all be true at the same time. You'll only be able to derive true lines. If you derive the conclusion, you've shown the argument's valid, proof method works. So either way, proof method's fine. So that's what happened here. Okay, let's move on to the next example. Again, we have 5 premises. We got a lot of conditionals. This will be fun. And a disjunction up on premise 1. Notice, if we look at 2 and 4, if R, then S and K. If S and K, then R. This is interesting because we have 2 conditionals, and this consequent matches that antecedent. Okay, so we could do a hypothetical syllogism, right? We could say, okay, here's the middleman is R. Let's cut the middleman out and go from S and K, then S and K. So we could do that, but these also match, right? This consequent also matches that conclusion. So we could cut that middleman out and go if R, then R. Okay, we could do either one with this. I'm going to go and do the first or the second one. I'm going to go if R, then R by hypothetical syllogism on 2 and 4. Why? Well, because, dig, this is now the negation of this disjunct, if R, then R, and this is not if R, then R. So I can do disjunctive syllogism on 6 and 1 to get the other disjunct, K. And now this is the negation of that consequent, so by modus tollens I can get the negation of this antecedent, S and A. I can simplify A from line 8, that's the second conjunct, I'm simplifying that off. And now notice 9 is the antecedent of line 5. A, I can get if B then K, that's by 9-5 modus ponens. And remember what I'm trying to get is not B. And that's good because I have the negation of the consequent. I can infer the negation of the antecedent, which is not B, by modus tollens on 7 and 10. Okay, and that is it for section 3.3.